Hi, you guys. So today we're going to continue on with lesson 2. So if you remember in the previous lesson, we were working on how to multiply by tens and create larger groups across place values, different place values. Today our learning target is I can recognize a digit. I can recognize a digit represents 10 times the value of what it represents in the place to its right. So we're going to continue on with what we started talking about yesterday, but you'll notice that our place value chart looks a little bit different than it did yesterday. So in lesson 1, we saw that our place value chart started at the ones place and ended at the thousands place. And today we're going to be continuing that place value chart on to some new places that we haven't looked at yet. So let's take a look at our first example of what we're talking about today and using our knowledge from what we learned in lesson 1 to help us with that. So we're going to take a look at 100, and I want you to think about the relationship between 100 and 1,000. How is 100 related to 1,000? So another way to say that is, how could I look at 100 and what would I have to do to that 100 to get to 1,000? So think about what we did in lesson 1. How are we able to turn 100? What do we have to do to it to get to 1,000? And ready? The answer is multiply it by 10, right? If we take the hundreds and we created 10 of these, we multiplied it by 10, meaning that we created 10 circles in the hundreds place. That's 10 hundreds. Then that actually creates 1,000. 10 hundreds is 1,000. So let's continue on. Let's think about 1,000. If we were to take that 1,000 and multiply it 10 different times, so use your imagination right now, seeing this dot, if we had 10 of these and we counted them all by thousands as we laid them out on the chart, what would we get? Let's try it. So we have 1,000, the next is 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. We know something magical that happened anytime we hear that number 10, when we are counting in any of the previous place values, we know that that means something really important. That means it's going to have to cross that magical divide between thousands. And what is that new place? What did I say that we ended on? It was 10,000. It created 10,000. So we have a new place on our place value chart called the 10,000s place. Let's continue that on. So now that 10,000s is a part of our chart, let's go ahead and count by 10,000s. What do you predict is going to happen based on the pattern that you've seen yesterday, going from ones to tens, hundreds, and thousands, and going from thousands to 10,000s today? What do you think is going to happen when we multiply this times 10? What do you think will happen? So let's count. We've got 1 10,000, 2 10,000s, which what is 10,000 and 2 10,000s when we say that? It would be 10,000, 20,000, 30,000. It's just the same thing as when we count by tens. 40,000, 50,000, 60,000, 70,000, 80,000, 90,000, 100,000. We have 10 of these new 10,000s, and 10 10,000s is actually 100,000. So we now have another place called the 100,000s place, and that's created anytime that we have 10 10,000s. All right, so we multiplied by 10 and we got 100,000. So let's take a look at the same thing, 100,000s. Oops, I think we froze a little bit. Oh, no, we didn't. We're doing a different problem. So all of a sudden I sneakily added the millions place in there. And what do you think is going to happen? How does that millions place form? From 10 100,000s. That's right. We're not really going to work with the millions a whole lot today. So I didn't create a visual of that. But what we're going to do now is a new problem. We're going to look at what 4 10,000s is if we multiply that times 10. So we're going to do 10 times 4 10,000s. So let's take a look at what that's going to look like. It's going to be really full. I hope that you are ready for this. We are going to be taking those 4 10,000s and multiplying each one times 10. Are you ready? Holy moly, did you see what just happened? I multiplied and I have 10 of the first 10,000, 10 of the second 10,000, 10 of this third one, and 10 of this fourth one. That means, holy moly, do you see how many I have? 10, 20, 30, 40, 10,000s. That's way too many to have in the 10,000s place. And what we learned in the previous slides before is that each of those 10,000s makes 100,000. So there is a 10,000 group of 10,000s, and that makes a 100,000. There's another group of 10,000s, and that makes another 100,000. This group also makes 100,000, and this group of 10 also makes 100,000. So 10 times 4 10,000s is actually 400,000. Let's try another one. So we have 300,000s, and we're going to multiply that times 10. So again, make a prediction. This time I'm not going to draw all 10 of each of those. I want to see if you can predict, where do you think those 300,000s are going to end up after the time we multiply them by 10 and create 10 of each of them? Well, what do you know? You're right. We actually ended up with 3, and look at that. They did end up in the millions place here. So we would call this 3 million. All right, let's take a look at this. Oh my gosh, wait a second. What just happened? 2,000s, but now it says we're dividing by 10? Wait a second. We've only been multiplying by 10, so now I'm confused. How will I divide by 10? Let's remember what division means. Division means that you're taking a part and dividing it into equal groups, but I'm confused. How in the world will I divide 2,000s by 10? I only have 2. Well, I'm remembering what we did in the previous work from lesson 1 and what we've looked at today. And every time I'm remembering that when I'm making groups of 10, I can go over to the next greatest place value. But I'm thinking, how would I take apart into groups of 10? Oh, wait a second. If you can make a group of 10 and it makes something bigger, if I take this one and break it into groups of 10, then perhaps that'll get me equal groups so that I can see what I'm left with after I divide by 10. Okay, so let's try that. I'm going to break it apart, just this 1,000 right here. And I know that if I'm going backwards into the hundreds, how many hundreds make 1,000? We know our magical number anytime you cross this line is 10. So let's see. There's 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So I just took that 1,000 and turned it into 10 hundreds. I could do the exact same thing for this one also, because I have 2,000s. I need to break both of them into 10 equal groups. So 100, 200, 300, 400, 500, 600, 700, 800, 900. You could say 1,000, but I'm going to say 1,000 because that's what we call it on our chart. And how many of these hundreds do we have in every single group? We just broke these apart into 10 equal groups. And how many hundreds do you see in each group? I see 200 in each group. There's 200, there's 200, there's 200. So when I took 2,000s and broke them into 10 equal groups, I have 200 in each group. So 2,000 divided by 10 is 200. All right, let's try this with another one. I have a weird circle in a weird spot. That's okay. So we're going to do 300,000s divided by 10. Okay, it's the same concept. We're dividing this time like we did in the last problem. We are not making bigger groups. We are actually going to be breaking into smaller groups. So we're going to start with this 300,000 right here. And what do you predict is going to happen? Without breaking apart every single 100,000, we know that those 300,000s are just going to end up sliding on over into the 10,000s place, because each of these gets broken into a smaller group of 10,000s. And how many are in each group? Just like in the previous problem, there were 200 in each group. This one actually has, instead of 300,000s in each of these groups, we have 3 10,000s. What is 3 10,000s? We don't say 3 10,000s. We call them by tens. It would be 30,000. So 300,000 divided by 10 is 30,000. And this is kind of the shortcut way of doing it so that you don't have to draw 10 of every single one every single time. This is a little shortcut. Okay. Oh, those random circles just keep popping up in weird places. Okay, so now we're going to take 300s, 2 10s times 10. Oh dear, now it's flip-flopping back and forth on us. So we're not dividing, we're multiplying by 10 this time. So we know when we're multiplying, we're making larger groups, not breaking into groups of 10 or 10 groups. We're multiplying by groups of 10. Okay, so let's take a look at 300s. What do you anticipate is going to happen? Those 300s are going to create, oh, what do you know? They're disappearing out of the hundreds and moving into the thousands, because every time we multiply 100 times 10, it creates 1,000. And what do you think is going to happen over here to these tens? Same thing. If we were to draw 10 of each of these, we would take the 10 tens, turn them into 100. Same thing for the second 10. The second group of 10, we would have another group of 100. So when we look at the answer to this, we see that we started with 300s and 2 10s, and when we made groups of 10 for each of them, we end up with 3,000, 3 in the thousands place, and 200. Okay, let's take a look at this one now. Oh man, we're getting into some complex problems here. We have 4 10,000s, 2 10s. So there's my 4 10,000s and my 2 10s. And I'm going to divide. They keep going back and forth on me. You really have to pay attention to those symbols. We're going to divide by 10. That means we're going to take these and make 10 equal groups over here. And these and make 10 equal groups over here. Okay, so I want you to pause and I want you to try this. I want you to see if you can figure out how you will divide by 10. When you're ready, hit play. Okay, are you ready? We're going to try it and see where you ended up. So we're starting with our 4 10,000s. We're going to divide them into 10 equal groups. And what do you think? What did you find? What did you get? Look at that. Each one of those 10,000s gets moved over into the thousands because each 10,000 gets broken into equal groups of 4,000. Each one gets broken into 4,000s. We're going to end up with 10 of those groups of 4,000. Same thing over in the tens place. So we're going to take a 10 and turn it into equal groups over here in the ones, and the shortcut way, so you don't have to draw 10 in every group and then look at every single group to see what you have. We know that when you have 10 or 2 10s and you break them into 10 equal groups, you're going to end up with 2 1s in each group. And that one's an easy one to check because you could just count what is 2 times 10. Oh yeah, that's 20. And that's what we started with. So that's kind of just a good way to check yourself on that. Okay, so we ended up with, we started with 4 10,000s, 2 10s, divided by 10. And we end up with 4,002. And that's our answer right there. All right, so you guys, here's the learning target again. I can recognize a digit represents 10 times the value of what it represents in the place to its right. Feel free to go back and watch this video as many times as you need to so that you can understand how I jumped from creating all of those individual dots of 10 to the shortcut way where I just know how many are going to be in each group. All right, you guys, happy learning and good luck on your assignment.